Today, we're going to start the actual lessons related to organic chemistry. So yesterday, you just talked a bit about properties of ionic and covalent compounds. You also reviewed some covalent bonding. We had done that in Unit 1. But today, we're going to start to talk about the main element that is pivotal to organic chemistry, and this is the carbon atom. So in order to complete lesson 2, we have to go back into lesson 1, and you see it here on my screen, and you have to click on the main resource note, which is 2.1. It's called molecular compounds. So I mentioned this in the lesson that I tend to use the term covalent compounds. Some people use molecular. They mean the same thing. Okay, so you're going to see us using those two terms interchangeably. Molecular and covalent mean the same thing. So this is what we did in lesson 1. We're going to just scroll down. This is, again, reviewing properties of ionics and covalence, reviewing bonding. And then you get to the end here, right here, where it says lesson 1 ends here. And now for lesson 2, we're going to start to talk a little bit about carbon. So I've made a summary note for you. You're going to read through all of this. You're going to click on each of these, okay, little drop downs. And you're going to make yourself a note about the main properties of carbon that make it so suitable for this branch of chemistry. Okay, so organic chemistry. And same here, naming simple organic molecules. You're going to go through and read through all of this and jot down some examples as I direct you in the summary note. Then what we want to do is we want to get you to start to draw out some of these organic molecules. And organic molecules are all carbon-based, okay? So they have carbon atoms that are linked together. And then quite often, they have all these hydrogens that are attached to the carbons. And sometimes we can have other non-metals, but organic molecules are covalent, okay? So we never, ever have any metals present. And what we do is, because we are aware that carbon has 4 valence electrons, okay, and you're going to go over this in the beginnings of this note, we always want to make sure that carbon is bonded 4 times. So sometimes, if you look right here, he's bonded to the other carbon that's next door, but he's also bonded to a hydrogen above, a hydrogen to the left, and a hydrogen to the bottom. And so this carbon always makes 4 bonds. And this is extremely important for us to remember, because this is how you can make mistakes and errors when you draw Lewis structures for organic molecules, if you don't remember that they always have to make 4 bonds. So sometimes what we do is, instead of drawing out our Lewis structure like this with all the hydrogens, we condense them. Okay, so when we condense something, we make it smaller. And if you take a look at this first carbon, he is bonded to 3 hydrogens. So if we just translate that over here, we see how they write that with a carbon and 3 hydrogens. And that sort of represents a little unit, okay, a little carbon unit within the molecule. The next carbon is bonded to 2 hydrogens. So that's like another little carbon unit. And this is why they'll show it as CH2 next door. And then lastly, the last little carbon unit is a carbon bonded to 3 hydrogens. And then we write that on the end as CH3. So this is why you see, different numbers of hydrogens as we move through a condensed structural formula, simply because what they're doing is, for each carbon, they state, what's attached to it. And it doesn't matter which carbon we pick, we always have 4 bonds. Okay, really, really important. Sometimes the carbons will bond to themselves twice, okay? So sometimes they'll make a double bond, and they still maintain 4 bonds per carbon. So if you look at this first carbon, he's bonded to 2 hydrogens, but then he's double bonded to another carbon. So we've still got 1, 2, 3, 4 bonds around that carbon. And again, we can condense this down and just group those hydrogens as we see over here. But notice how they maintain the double bond in between. Very, very, very important, okay? Because a double bond versus a single bond versus a triple bond are very, very different. And you have to be sure and detailed that you represent it properly, okay? So what we're going to have you do here is we're going to have you practice a little bit and just pay attention, right? So you've got different numbers of carbons and then you have different numbers of hydrogens. And, if you have all single bonds, then, you're going to be placing a hydrogen around all of your carbons. But if you don't have enough hydrogens for the formula, then what you'll need to do is you'll have to be putting in double bonds somewhere. Okay, so go through and give these a try. They do have a little video of an explanation for all of these. And then I'm going to leave a worksheet for you to complete on just some simple organic molecules, drawing them and placing carbons and hydrogens together. All right, enjoy this. This is brand new for everybody. You got to make sure you try it and be in touch if you need any help.